Alright, in this video we're going to discuss how do you graph a quadratic function. Okay, we know, or many of us know, that the name of a quadratic function is a parabola, and that's what we're going to try to graph. We're going to focus on two different varieties of quadratic functions, or two different forms of quadratic functions. One is this form, y is equal to, or f of x is equal to, a times x minus h squared plus k. All right, and this form, in your current textbook, it refers to it as standard form, but I've always known it to be vertex form, because the great thing about this is it tells us exactly where the vertex is. The vertex is always at the coordinate, or at the point h, k. Notice that the y value will remain the same sign, but the x value changes signs. And that's because, you know, really what we're looking at here is transformations. Here we're going to the right h units and up k units, right? So if I'm going to the right, it would be positive. All right. So that's one great thing about vertex form. We're going to talk, let's actually talk all the way through that one, okay? So if we know this to be true, let's go up and look at this example. Negative x minus 1 squared plus 4. Okay, so we want to know, first of all, what's the vertex? Okay, so I want to just pull those directly from the equation. What is h? What am I subtracting? Well, I'm subtracting 1. And what is k? Well, that's 4. So our vertex, I can't reach that high, is going to be 1, 4. Okay, now remember that a parabola is kind of a U-shaped graph. It will either open up or it will open down, depending upon your a value. If a is positive, well, then we have a happy graph because it is opening up like a smile. If a is negative, well, then we've got a sad graph and it opens down. Okay, so we know, this is what we know. We know that our vertex is at 1, 4. Let's see, 1, 2, 3, 4. And we know that since it's negative out in front, where it's going to open down. We're not exactly sure all the parameters here, but we know that much. Okay, so how do I go ahead and graph it from there? Well, depending on who your instructor is, you may be able to get away with just, you know, a U-shaped graph turned upside down through that point. But if I'm your instructor, that's not enough. Okay, so we're going to go and we're going to say, well, what is the vertex? The vertex, we said, is 1, 4. Now I'm going to think about what is this x value minus 1 and plus 1. And I'm going to sub those values in and get some coordinates of other points. If I subtract 1, it's going to be 0. If I add 1, it's going to be 2. Let's take and find f of 0. Plug that 0 in here. 0 minus 1, negative 1, right? Square that. Negative 1 squared is positive 1. Then apply this negative out here. So we're back to negative 1 and add 4. Negative 1 plus 4 is 3. Now let's do that for 2. Plug in the 2. 2 minus 1. 2 minus 1 is 1. Squared is also 1. Apply the negative. Negative 1 plus 4, also 3. Now, the great thing about using this plus 1 minus 1 thing is you should get the same y values out. So if you know that, you don't have to actually do it twice because you'll get the same thing out. That's because a parabola is symmetric. It is the same on the left as it is on the right. Okay, so let's go ahead and plot these 2 points. 0, 3, right here. And 2, 3. Awesome. Okay, so now, what is the y-intercept? Well, we know that here because we can see it on our graph. But what if we didn't know it? How would I find a y-intercept? Algebraically, what do you do to find a y-intercept? You put a 0 in for x and you solve for y. So to find your y-intercept, you are looking at f of 0. So let's go ahead and plug that in. We know what it's going to be, right? Negative 0 minus 1 squared plus 4. You can do that all in your calculator, but we just did it, and we ended up with 3. Okay, so our y-intercept, in this case, we have 0, 3, already come up with it. Now, how do you find x-intercept? You could have 0, 1, or 2 x-intercepts with a parabola. Well, instead of putting a 0 in for x and solving for y, you put a 0 in for y, or we find where f of x is equal to 0. So we say 0 is equal to negative x minus 1 squared plus 4. Okay, so to do this, what we're going to do is we're going to move this 4 to the other side. We're going to clean this up. Okay, so if I subtract the 4, I end up with negative 4 is equal to negative x minus 1 squared. I'm going to divide both sides by negative 1. So I would have 4 is equal to x minus 1 squared. I'm going to take the square root of both sides, and remember, when you take the square root and you've got a variable involved, we need a plus or minus. So this is going to be plus or minus 2 when I take the square root. And when I take the square root here, the squared and the square root are inverses of each other, so we just get x minus 1. So I get 2 answers out. I've got x minus 1 is equal to 2, and I've got x minus 1 is equal to negative 2. For this one, x is equal to 3, and for this one, x is equal to negative 1. So let's go ahead and put those in. We know this is 3, 0, and this is negative 1, 0. Let's go ahead and plot those. 3, 0, and negative 1, 0. So we are seeing that our graph is starting to take the shape of parabola, and we can go ahead and go like this. Okay. Now I can ask you all different kinds of questions about this graph. Once I've got my graph like this, I can ask you questions like, what is the domain of this graph? And you should be able to look at the graph and say, well, the domain, it goes infinitely to the left and infinitely to the right, so my domain is all real numbers. I might ask you questions like, what is the range of this graph? And you would look at your graph and go, well, it goes infinitely down, comes up to the point where y is equal to 4, so my range would have to be negative infinity to 4, including the 4, so bracketed. Might ask you for things like, what is the axis of symmetry? The axis of symmetry is the vertical line that splits the graph right in half. Okay, so, you know what, let's just record all these things. Our domain, we know, is all real numbers. Our range, we know, is negative infinity to 4. Our axis of symmetry is that vertical line that splits the graph right in half, goes right through the vertex, okay? So remember that when we are talking about a line, we always use an equation to represent it. X is equal to 1, okay? And it's always going to be x equals whatever the x-coordinate of the vertex is. All right, what else we got? Oh. Does it have a maximum or a minimum? We're talking relative max or min here, right? And in this case, it opens down, so there is a maximum. There's no minimum because it keeps going infinitely down. But remember, a relative max is somewhere where it changes from increasing to decreasing. So our relative max, how high does it get there? I think that's the same thing. Our maximum is 4. Okay, where does it occur? Where does that maximum happen? That's going to be the y of your, I'm sorry, the x of your vertex. X is equal to 1. All right, what else we got? Intervals of increase, decrease, and then where is your graph, where's your function above and below the x-axis? So, intervals of increase and decrease. For parabolas, they're half and half. they're going to increase and then decrease, or they're going to decrease and then increase. So we think about the point of change being that axis of symmetry. So let's think about what is this interval. From this to this is going to be negative infinity to 1, and then from here over is going to be 1 to infinity. Well, what's it doing on this side? It's increasing, and what's it doing on this side? It's decreasing. And then the last thing that I might ask you about would be, where is f of x? Notice I said where, right? Where is f of x greater than 0? That's asking for where is this graph above the x-axis. And I look at this graph and I say, well, from here to here, right? From here to here, everything is above the x-axis. Another way to think about it is cover up everything where it's below the x-axis, and then just give yourself an interval on the x-axis where it's above. Okay, well, where is it? That is from negative 1 to 1, 2, 3. Okay, so that would be from negative 1 to 3. Now, where is it below the x-axis? That's a little trickier because that's the ends of the parabola. So it's from here over, and it's from here over. In other words, from here to the left and from here to the right, right? Everything from here over is down below the x-axis. Everything from here over is also below the x-axis. So negative infinity to, let's see, all the way up until we hit that x-axis at negative 1. And then also from 3 to infinity.